If you watched the last video on validation and input masks, we used some comparative operators as an example, and we're going to do that again with queries. So first of all, you probably would recognize these symbols if you have ever done a maths GCSE or ever taken a maths class in your life and were awake. So let's try use the first one as an example. So I'm going to look at my database that I set up earlier. Here's my films database, and I'm going to look at the customers. So these are all the customers on my database, and I'm going to do a simple query. So to set up a query, click on create, click on query design, and then what you'll see here is a pop-up that allows you to choose from the 3 tables that I have. For example, I've got 3 tables on my database. I'm only going to use customer table, so I'm going to click on add just a customer table, and I'm going to click on close. Now the next thing I'm going to do is I'm going to add every single field name. As you can see, as I'm double clicking, it's filling in the table below. Alright, so now I've got every single field name along here, and I'm going to try by looking for let's use one with a comparative operator. So if I click on view, I get to see every single customer in my table. However, this isn't my table, this is my query. If I click on view again, it takes me back to the criteria view. Now what we're looking for is we're going to look on ledger, and we're going to find all customers with an account in credit of £3. So I'm going to type 3. I'm going to type 3 as a criteria. Now when I click on run, it will filter down, it will filter out every single customer that doesn't have 3 in the account, exactly £3. So these customers, and it tells us here at the bottom that we have exactly 6 customers, 1 to 6, that have exactly £3 in their account. So let's go back to view, and now let's start using those comparative operators. So if you remember, the first one was more than. Let's try looking for all customers with a ledger of more than 0. So all customers that aren't 0, let's have a look, and we have quite a lot more. We have 55. Okay, so you can see as we look up and down this list here, you'll see that every single customer here has a ledger in credit, so they're not in debt to our video company. Let's go back again. Let's look at less than. Let's look for all customers that have less than 0. So these are customers that are now in debt. There we are. And we have 39 customers that have a ledger of -0. So these are all customers that owe money, probably in late return fees or whatever, to the company. So in the same way that I've done less than and more than, obviously I can do the same with let's say more than or equal to. Let's say more than or equal to 0. So that means all customers that are in credit or do not owe any money. So these are all customers that are not in debt, including customers that have 0 in their account because they're not in debt. This is 62. So there are 62 customers with no debt. Now what we could do is we could say, for example, all customers that are not equal to 1. So all customers that have any number in their ledger other than just £1. And again, there's quite a few there. So there should be no one here with just £1 in the ledger. Okay, so that's a quick example of how to use the comparative operators. Now let's try some other criteria. Let's try and marry that up. In fact, let's do a string. Okay, so for example, let's look for all customers, let's say, with the first name John. Let's try John, and let's see what comes up. None. So we have no customers by the name of John. That's oh gosh, who do we have that we can just try for an example? I can see we have a Joby, we have a Janine. Let's try. It seems to me that these are probably quite unique. They seem like they are. Okay, well that actually like helps me with something else. Okay, first of all, let's see. I can see for a first name, we definitely have. Let's go with Mile and Scarface. Wow. Okay, let's go with Scarface. So first name, Scarface. So what it's doing now is we're doing what's called a string search. We're searching for a string of characters together. So if I click on run, there was one person with the first name Scarface, and I suppose you can tell that the names and all the names and data that I've generated in this database is from a random table, so from a random generator. That's how people have the first name Scarface, and Scarface has a ledger of -1. So what's interesting is we can do a string search to look for something exact, but it would be interesting as well if I used the like search. So if I search for like and I type in, let's say AL and then a star. Now what this should do is it should look for all names that begin with AL, and it could end up with anything else, but it's going to look for all names that have AL. Let's have a look, and we have a few. So we have Alice, we have Ali spelled in a different way, and Alicia. So that's another operator you could use. So I said look for, I use a like keyword. So you see me say like, and then I've typed in inside the speech marks AL, and then the star, which really represents, it means wildcard. Okay, so now what I want to do is I want to search for all names beginning with A, and I also want to add a second criteria. So as well as searching for a first name, I also want to search for customers between a certain date of birth, so people born before and after a certain date. So let's type this in. Let's type in like A star. So all customers beginning with a name A. Does that work? There we are. All customers with the first name beginning with A. Okay, and now let's narrow down a bit more, and we want to find customers born after a certain date. In fact, let's go back for 1 second, just double check. If I put this in order here, I can see, let's do newest to oldest. Okay, so, well, the latest date of birth here is 1993, and the earliest is 1970. Let's do a search between 1980, so that should eliminate 1970, and let's do a search, well, let's say up until December the 31st, 1990, so that should eliminate the 1993 there. So we have 7 records currently. Let's see if we can narrow that down to 5. So let's turn back, let's go to our date of birth, and we're going to do a search that is more than or equal to hash, we said the 1st of January 1980, oops, that's 1981, so we want to eliminate the 1970 hash, and we want to use an AND, so it's between this date and this date. So we said up to 31st of the 12th 1990, I believe it was, or was it 91? We'll soon see. Okay, let's tap that in, see what happens. Oh, I didn't put a hash there. Let's try that. Oh, none. What was my mistake? And oh, my bad, I didn't put a less than equal to either. So less than equal to that date. There we are. Alright, so has it done that? Well, yes, it's eliminated the 1993, and if we put this in alphabetical order, so oldest and newest, it's eliminated 1993 and it's eliminated 1970. So if we look at the bottom here, it does say 5 records, so we've eliminated 2. So there we use an AND search to look for 2 dates between, well, date of births between a certain time. So we had to use the AND operator in between 2 dates there. Right, let's try one more. Let's try an OR operator as well. So let's say we want to look for all names beginning with A, or like beginning with D. Where's my star? So Here we're looking for all names beginning with A and all names beginning with D. There we are. And if we put this in alphabetical order, oops, oh, is that right? Sort A to Z. Okay, there we are. So here we can see all names beginning with A and all names beginning with D. So there, in this example, we've looked at also how to use the AND and the OR operators.